AI Agents, General Settings. The General tab is your entry point for defining the agent's identity, purpose, and functional scope. It's designed to help you articulate what the agent should do and how it should behave in conversations with users. The General tab contains three main subtabs. Objective, define the agent's primary purpose. Actions, specify what the agent can do to achieve its goals. Flows and channels, link the agent to specific conversation flows and deployment channels. The Objective subtab allows you to define the agent's main goal, a clear, actionable statement that guides the agent's behavior throughout conversations. You can write the objective manually using the rich text editor, which supports Markdown-style formatting for better structure and readability. Use tools like bold, italics, bullet points, and links to make your objective more expressive. Alternatively, you can ask AI Assistant for a help, the button located in the top right corner of the objective field. The assistant is able to improve objective, fix grammar, make the objective shorter, review, and constantly review your objective while you're composing it. You simply describe what the agent is supposed to do. For example, Small Talk AI Assistant for scheduling calls, and it will automatically generate a well-structured objective based on your input. The token counter below shows how complex your input/output is, which helps in managing limits. Actions. The Actions subtab allows you to define specific operations that your agent can perform to fulfill its objective. Each action is a discrete function the agent can invoke based on user input. You can create new actions or edit existing ones. Actions can be created in UI mode, form-based, or code mode in GraphQL Schema Editor. Switching between the two is seamless, allowing both technical and non-technical users to work efficiently. Required fields when creating an action. Name, a unique identifier for the action. Description, a short summary of the action's purpose. Definition, GraphQL schema defining the input and output structure. Example, a specific use case showing how this action is intended to be used. The AI Assistant can help you to create an action as well. Describe what the action should do. The assistant will generate the structure and sample schema automatically. Input and output definitions. Each action includes a definition of inputs, what the agent needs to perform the action, and outputs, what the agent will return after executing it. These are written using GraphQL syntax for precision and interoperability. In UI mode, you can add properties with friendly names, select their data type, for instance, string, float, Boolean, mark whether they are required, write descriptions for input and result schemas. If you prefer working in code mode, here's an example schema for retrieving weather data. Example section. The example section allows you to showcase how an action is executed within a realistic conversational context. This isn't just a code snippet. It's a complete simulation that reflects the agent's reasoning, communication, and decision-making process leading up to the action's execution. To be effective, the example must reflect a true interaction flow that naturally leads to the need for the action. Demonstrate the agent's logic and communication structure across components like user and assistant messages, thoughts, actions, and observations. Be relevant to the purpose of the action and make the motivation behind its execution clear. Example structure. A typical example follows a pattern similar to: each user message initiates the agent's thought. The agent then generates an assistant message that can either proceed with an action, then to observation, and then to follow-up response, or wait for the next user message. At the end of the interaction, regardless of the branch taken, the conversation can naturally continue, forming a loop between assistant message and a user message. You can start the example from any component, for instance, just a thought or a direct action, as long as it realistically fits the expected usage of the action. This example demonstrates a realistic scenario where the user doesn't know their current location. Before triggering the getWeather action, the agent must logically follow a reasoning path, first determining the user's geolocation, and then retrieving the appropriate weather data. This illustrates how actions should be contextually justified and not executed in isolation. This example can be essential because it clearly demonstrates how a GraphQL query should be structured for a given action, and what kind of data or context is expected to trigger the action during a live conversation. Flows and channels. In this final subtab of the general section, you'll see which flows and channels are connected to the current agent. Flows refer to complete, structured solutions where the agent is embedded and actively performs tasks. These are not simulations. They represent real execution environments with end-to-end logic, such as handling user input, invoking actions, managing states, and producing outputs. A flow might include conditions, branches, action calls, and more. Essentially, it's the operational logic that leverages the agent. Channels determine how and where the agent is deployed. For example, web chat, voice, SMS, etc. This view is read-only and helps you quickly verify that your agent is linked to the correct deployment paths. Thank you for your attention. Stay tuned.